Now in this lesson we're going to be looking at permutations. Now another way of thinking about permutations is they are ordered selections. When a given number of objects are arranged and their order is important, the arrangement is called a permutation. An example: how many different ways can the letters A, B, C and D be arranged if all four letters are used without repetition? Well, while solving that, we're going to draw a list up firstly. We're going to look at two methods. We'll draw up a list and then we'll look at an alternative method. Let's start with A and let's systematically list every arrangement of the four letters. Well, we could have, of course, A, B, C, D, then A, B, D, C. Moving on from A, B to start with A, C, B, D, then A, C, D, B. Then moving on to start with A, D. We'd have AD, BC, then AD, CB. And that's what I mean by being systematic. Alright, now that seems to have exhausted all the ways we could have A to start with. So we move on to start with B. BACD, BADC, BCAD, then BCDA, and then moving on to BD, BDAC, BDCA. So we've used up all the B's at the start. We move on to C, and this is the results we're going to get. Okay, that exhausts the C's to start with, and finally starting with D's. Okay, so how many different ways? Well, if we count them up, there are in fact 24 ways of that happening. Okay, now that wasn't too bad. Alright, so that's one way of doing it. Alternatively, we can consider this. We're trying to fill up those four boxes with those letters, A, B, C and D, okay? Now let's consider, if we were to put one of the letters in that first one, we've got four to choose from. So we can do that any one of four ways. Now, moving on to the second one. Once you've put one of the letters down, there's only three letters available to fill up this second position. So there's three ways we could fill that up. Now at this stage we've put down two letters. So when we get to this position, there's only two letters to choose from. There's two ways of doing that. And our final position, we would only have one letter left. So there's one possible letter that goes in there. Now the number of ways, what we do then is simply multiply those four numbers. 4 times 3 times 2 times 1. Then we get 24. Okay, obviously those numbers, our answers should match up both ways. Okay, so we're going to be concentrating in this lesson on doing this alternative method, okay? Hopefully you're fairly familiar with writing up lists. And we're going to be, this lesson, concentrating on the number of ways using this alternative method. Another example, how many ways can the letters from the word crate be arranged? Okay, our solution then, well, the word crate has 1, 2, 3, 4, 5 letters, so 5 boxes. Our first box, alright, our first letter can be chosen from the whole 5 of them. Now once we choose one letter, one letter's down, in our next position we've only got 4 letters to choose from. Then it goes down, we'll only have 3 letters to choose from. Okay, then we'll have 2 letters to choose from, and finally there would only be 1 letter left to put down. So the number of ways, again, we just multiply all those numbers, we get 120. Alright, now in this case you wouldn't particularly want to draw a list, okay? That wouldn't be very reasonable, because you'd end up coming with 120 ways. That list would take too long. Another example, in how many ways can we arrange the letters of crate if we use only 2 at a time? Okay, well we could actually draw a list up for this way, it wouldn't be too bad, but let's look at solution this alternative method. This time only 2 at a time, we're not using all the 5 letters, so 2 boxes, okay, representing the 2 letters we're choosing. Okay, that because they're all coming from the word crate, there's 5 letters, so at the start to choose we've got 5 to choose from, so there's 5 ways we could choose that first letter. However, once we've chosen one letter, in our next position there would be only 4 left to choose from. Okay, so the number of ways, simply 5 times 4, which of course is 20. Excellent. Another example, in how many ways can 12 objects be arranged if we take 4 at a time? So our solution, we're taking 4 at a time this time, so we've got 4 boxes to fill in from 12 objects. So our first position, we can choose from all 12, so there's 12 possible ways of choosing that. Then once we choose one, would be then down to 11, then down to 10, then finally down to 9. So the number of ways would equal 12 times 11 times 10 times 9, works out to be 11,880 ways. No way are you going to draw a list up, of course, for this sort of question. Our final example, a race has 7 competitors. In how many ways can the first 3 placings occur? Well, the solution, first 3 placings. So we're after 3 placings. It has 7 competitors. So to find first place, well, any one of the 7 can fit first place. Once first position's filled though, there's 6 places, 6 competitors can fill second spot, and once those 2 positions are filled, third spot, there would be 5 left to choose from. So the number of ways, 7 times 6 times 5, works out to be 210. Now just a note on this last question, in horse racing, the order of the first 3 place getters is known as a trifecta. Okay, so often you get questions in an exam situation which relate to some sort of real life situation, particularly in this case a horse racing trifecta.